And remember, a rational function looks like this. The parent function I gave you yesterday looked like this. This function had a vertical asymptote at x equals 0. And it also had a horizontal asymptote at y equals 0. Imaginary lines at x equals 0 and y equals 0. When it was -1, this value was -1. When it was -2, it was -1/2. So the function did this on this side. And on this side, when it was +1, it was +1. It was +2, it was +1/2. So it did this on this side. All rational functions look like this. They're defined by their asymptotes. So you have the vertical, which we know how to find already. The horizontal. The horizontal works off of 3 rules. There's 3 rules we're going to look at when we talk about the horizontal asymptote. Horizontal asymptote looks like this. When you write your function f of x, you have the numerator function at the top, denominator function at the bottom. And when you look inside of here, you're going to always write these functions in standard form. So ax to the n will be the first term at the top, and bx to the m will be the first term at the bottom, leading coefficient at the bottom. So both these terms are leading coefficients for their respective parts. What does it mean to be the leading coefficient? The highest what? Thank you, good. So I'm looking at the highest exponents for both these parts. This is the highest exponent for both these parts. Whatever those exponents are, those are going to tell me what to do with my horizontal asymptote. And you have 3 rules. You're going to compare n and m. So we compare n and m. You're going to compare n to m. And it works like this. The first one says this. If n is less than m. If n is less than m, which means that the exponent on the top is smaller than the exponent on the bottom, your horizontal asymptote will always sit at y equals 0. Here's an example of what that means. Take the function f of x is equal to the leading coefficient 3x cubed minus 2x plus 1 over 5x to the 4th plus 3x squared minus 2. Are they written in standard form? Is the top part in standard form? Is the top part in standard form? Is the top part in standard form? I'll keep asking the question because I want you to say yes. The first answer was wrong. Why is it written in standard form? What's the highest what is the highest exponent in the top part? X to the 3rd. Is it first? Then it's in standard form. X to the 3rd is first, so that's the highest exponent. What's the highest exponent in the bottom part? 4. Is it first? It's in standard form. Everybody got that? Compare the top to the bottom. This top value is n, so n is equal to 3 and m is equal to what? 4. N is equal to 3 and m is equal to 4. When we compare that, n is going to be what here? Less than m. If n is less than m, the horizontal asymptote is always at y equals 0, regardless of what it is. It's always at y equals 0. And what that means is this. It's always y equals 0 because these are fractions. And what does it tell me about the fraction? If the number on top is always smaller than the number on bottom, what's happening to that fraction? Let's think about that. Let's talk about it in terms of pizza. Everybody got that? Is 1/2 bigger? If you have half a pizza, is that bigger than a fourth of a pizza? Right? If you have a fourth of a pizza, is that bigger than the eighth of a pizza? If you have a eighth of a pizza, is that bigger than a 16th of a pizza? Slice is what I'm talking about now, right? What's happening as the bottom gets bigger and bigger and bigger to your slices? Are they getting larger or are they getting smaller? Smaller, right? As a matter of fact, if you had an infinite number of pieces, basically, or if you had 100 pieces, how small would that be? Very small, right? Had 1,000 pieces, how small would that be? Very small, even smaller, right? If you had an infinite number of pieces, what would it go to? What would it be very close to? Your slice size would be how big? Practically non-existent, which is what number?
0.
So anytime the top is smaller than the bottom, as both these numbers get really big, the bottom's always going to be bigger. Does everybody understand that? And the bottom is always getting bigger and bigger and bigger. Where is it going to? What number is it going to? 0. So where does this rational function always go when the top is bigger than the bottom? It always goes to 0. Second one, when n is equal to m, HA is always going to be y is equal to a over b. And if you look here, a over b is going to be the coefficients of the leading coefficient term. So it's the coefficient of the leading coefficient term. So here's an example. Take the function f of x is equal to 3x cubed minus 2x plus 1 over 5x cubed plus 3x squared minus 2. This time, when I compare your leading coefficients, first off, are they in standard form? Is it in standard form at the top? Yes. What's the highest exponent at the top? 3. Is it in standard form at the bottom? What's the highest exponent at the bottom?
3.
So what is n equal to? What is the top exponent, n? 3. What is the m equal to the bottom exponent? So when you compare them, n is equal to m. Does everybody understand that? Which means the horizontal asymptote is that y is equal to a over b. Well, what's the a term at the top? What's the a term? 3. What's the b term? So y is equal to 3/5. And the last thing. So you have less than, equal to, and the last one's going to be greater than. When n is greater than m, you get your horizontal asymptote is going to be none. There won't be a horizontal asymptote. Because what that means now is that you can divide by the m term. And so we get what's called a slant asymptote. And a slant asymptote is a line. In order to find the slant asymptote, you have to use long division. We're not going to talk about that yet. We're actually going to, I just want you to tell me if it's a slant or not. So that looks like this. 3x to the 5th minus 2x cubed plus x minus 1 divided by 5x squared minus 3x plus 1. When I look at this, notice that the top exponent is a 5 and the bottom exponent is a 2, right? Are they in standard form? This time, so n is equal to 5, m is equal to 2. When you compare them, n is less than m. Everybody understand that? Or n is actually greater than m. I'm sorry. N is greater than m. So will I have a horizontal asymptote? No. Horizontal asymptote is going to be none. This means you have to find a slant asymptote. And we'll find that later, not today though. So we'll stop there. Alright,